Okay, fire away.
All right, I'm gonna give it a go. Hello, everybody. Welcome to this Charleston Conference webinar. My name is Jared Seay, and my colleague is Jeffrey Timms. And right for the start, let's learn a bit of Web of Science. Imagine, if you will, you're a student who has been told that in the next class you will take, you will be introduced to a database, and that you will use this database to search for sources for your upcoming assignment. Perhaps you're underwhelmed. Perhaps you know in your very soul that teaching anything about the library, and especially databases, is barely above the excitement of watching fresh paint dry, because you know that libraries are boring and that research is boring. And besides, even if this is not true, how interesting can learning about a database really be? So, it is with these preconceptions that you find yourself entering an oddly arranged classroom where you take your seat among two other classmates to which you have been teamed. And because you're still a very cynical student, you think, well, that's great, another group project. There are a series of odd items spread across the table in front of you, which does spark your interest, however. And in the center of the room, you notice a strange silver-colored contraption with lights from which emanates a barely audible hum. Then the lights within the room grow darker, and a news bulletin video appears on the main screen. It tells of a nuclear meltdown caused by some crazy guy in an Arctic research station that has trapped a group of scientists. In the video, it appears that these scientists are really screwed. But when the video ends, the instructor speaks in a rather over-dramatic voice. As fate would have it, your team, is one of those trapped in this very station. So you will have to work with your own team to shut down the reactor before it goes into full meltdown, dooming you all. Well, for a moment, you stare at your team. Then a message appears on your screen from that crazy guy, Sonia Nielsen, taunting you for being a slacker and obviously clueless about how this whole database thing works. A loud and very annoying klaxon warning horn starts to sound. I mean, very loud and very annoying. Apparently, you're about to be turned into a radioactive batch of slag. But then again, if you can get this database thing down, maybe, just maybe, you will actually survive. Geoff and I are going to relate how we developed and applied the concept of an immersive game to fully engage students in learning how to use a database. Each of us brings a unique background and skills to this. I have a lifelong love of playing and creating games and using them in instruction. Geoff has a history of developing web applications to enhance library user experience. Guess which one of us is going to have lots of money in the future? Let your mind wander back to the innocent and carefree summer of 2019. Geoff and I applied for and received an innovative teaching and learning grant from a small grants program at the College of Charleston. Inspired by a class Geoff was currently teaching about the Web of Science database, we settled on teaching basic skills in this database as our target. By searching in a database, reading the metadata, and engaging with the search fields, we wanted the students to tie into two of the concepts of the ACR framework for information literacy: searching as strategic exploration on a research database platform, and scholarship as conversation with citation mapping. Now, at the beginning, we were only sure of two things. First, we wanted to engage students more effectively in information literacy by problem solving and collaboration. And second, we wanted to make this happen by using an immersive game and put our students into a scenario in which they had to problem solve the way to success and survival using database skills. Well, as anyone who has ever experienced an escape room knows, there is one sure way to focus the mind and inspire and even compel participants to explore and seek out knowledge. All you do is you make exploring and knowledge seeking a precondition for not experiencing a horrible simulated death. Piece of cake. Thus, our scenario theme was as follows. An evil scientist at an Arctic research station has set the station's nuclear core into meltdown because the station is, of course, powered by a nuclear reactor. The players who represent the scientists now trapped at the station must shut down the nuclear reactor before it melts down and dooms them all to radioactive particulation. Since only he, the evil scientist, is the sole holder of the shutdown codes, the students must try to hack their way through the station's mainframe computer database. which looks remarkably like the Web of Science database. And this diabolical villain has left tantalizing clues and puzzles to these shutdown codes to allow the students to hack their way through several secure levels to reach the nuclear core and shut it down in time. Now that we had our motivation, we needed a game system to integrate this fear of sim death into a practical classroom experience. We wanted our game to have both digital and real world aspects. The physical part was the breakout box concept of putting clues and puzzles in locked boxes, which contained items, puzzles, and ciphers. The digital was in two parts. One, we used the quiz function in LibGuide's LibWizard as our core interface that guided the students through the game. And two, we used the exploration of Web of Science database to resolve puzzles generated by this interface to advance through escape boxes in the classroom itself. Now, I know all of this sounds very exciting and engaging because, well, it is, but let me talk a bit about what exactly the students are doing in the game to actually learn the database. The interface guides students through the database where they are taught how to search and filter for specific information or record fields. Basically, they are given a tutorial on how to use parts of the database, and via clues generated by the puzzles and the information found in the boxes, the students are guided to search for and find specific articles in the database. Within these articles, they are directed to identify specific parts of the record or the article, such as authors, publication dates, subject headings, details in the article abstract, or even document types. There's also a bit more complication added by the citation mapping puzzle. In this particular puzzle, the students must place a series of articles in the right-sided order. They then use a coded clue along with a cipher to solve a critical problem. This puzzle reinforces the idea of scholarship as an academic conversation by illustrating the citing string, but it also rewards those teams who can cooperate effectively in solving it. You might say this is an interactive tutorial wrapped in an immersive scenario game with the motivation of simulated radiation death as an additive motivation. Aha, you would be right. One of our design guidelines was that we wanted both cooperative and competitive mechanics. So we put the students into teams of 3, and each team member had to cooperate within their team to find clues, solve puzzles, and apply their database skills and knowledge. But even though each team competes to shut down their section of the core, all of the core sectors must be shut down in time or everyone is doomed. So cooperation is very necessary, especially near the end. To give ongoing feedback, we wanted a graphic, a kind of leaderboard at the front of the room that allowed everyone to see the progress of all teams as they move from level to level. This progress screen displayed the team's progress, countdown time, the rising temperature of the core, and the status of the various fuel cells, including the actual moment that they were shut down. I need to say that this aspect, the ability to use feedback from LibGuide to track and display each team's progress through the game, involves a great deal of coding and spreadsheet interaction. You have no idea. This became a significant amount of the work and time put into the game, especially for Geoff, bless his heart. So this aspect, indeed the entire interface, became the core, pun intended, development issue when we started adapting this game to a fully online experience. But more on that in just a wee bit. We beta tested the game with fellow librarians, and then again with some hand-picked students. We discovered and corrected some important game flow issues, and by January of 2020, we were ready to impose our immersive scenario experience upon a real classroom of real students, and looking forward to a very long semester of face-to-face interaction.
Okay, just transitioning with screen sharing here. Okay, so on that fateful day in early January of 2020, when the world was still innocent and things were fairly normal, we gathered a group of freshman students and launched our game. Our students were assigned randomly to their teams. There were 5 teams in all. And this meant that some students were working with people with whom they were already familiar, and for others it meant working with new people that they hadn't interacted with much in the class before. And we set out to observe and learn a lot about student behavior, which we certainly did. We noted right off the bat when the initial opening video of the game finished and we set the students to working that some of the randomly formed teams just didn't warm up to each other. And that really delayed their initial progress and took a bit of coaxing to get them to start doing things like talking to each other. We also noted that as students read the initial instructions and the initial information that they were provided on the interface and in a manila envelope that has some clues in it, we observed unexpected interpretations of the information that we had provided. In other cases, information was perceived by students to be completely unnecessary to progress in the game, and they tried to get stuck in without actually reading instructions or paying much attention to the clues. But this, of course, didn't go well. When it came to database searching activities, we designed them to include repetition so that students would be guided in learning how to use Web of Science features and get familiar with the interface, and then apply what they had learned in several searching exercises. We were surprised to see that some students did not necessarily connect the outcome or the process of a successful searching activity to the subsequent activity, which was very similar. So application of what was immediately learned was a bit of a challenge. And of course, it was no real surprise that at least one of those rascals tried to sidetrack Web of Science altogether by going to Google Scholar, which, as we all know, usually ends in some form of radioactive fallout. We were thrilled, deeply surprised, in fact, with students' ability to understand, interpret, and solve the citation mapping puzzle. We really thought that this would be beyond the freshmen, but the teams really engaged around this activity and succeeded rather nicely. As we observed students, we classified them into a variety of personas. To start with, we had bystanders. The bystanders failed to enter the thick of it with their team. And it's hard to know why, in every case, why this was so, because we only met these students the one time for this game. We had no history with them and no subsequent history after the game. But we did know that one team appeared to be made up entirely of bystanders, and it took a lot of coaxing to get them into collaborating at all. Also, one student arrived late to the class and missed the whole introductory contextualization of the game and found it hard to engage with his team, mainly because I don't think he knew really what was going on. The next persona is the self-proclaimed hero, and that persona's catchphrase is, "I got this." The heroes tried to undertake the tasks on their own as individuals, thereby suppressing any team collaboration. And honestly, sometimes they succeeded in completing the task, but at other times they led their team right up the garden path and had to ultimately be reined in so that progress could be made. Conversely, we did see some coordinators or leaders emerge, and a couple of those coordinated their teams while facilitating collaboration and enabling everyone to contribute. And of course, these were the teams that progressed the fastest. We had one case of dueling banjos. These were two team members who collaborated but seemed to be in competition with each other. And while they exuded a profound amount of energy, they had very little direction, which caused an outcome of very little or slow success. And then the most common role was the player who neither led nor lapsed, but did contribute their perspective in appropriate proportion and engaged with their teammates fairly successfully. We were delighted when, with 2 minutes to spare before particulation occurred, our teams defeated the game, they won, they saved the day, and their neurons glowed while they were at the library. And we were anxious to find out all about what they thought of this experience, so we surveyed them. A brief survey, and using Likert-type ranking questions, we were thrilled that overall the feedback about the game was pretty positive. We did identify a couple of areas where we wanted to pay more attention as we refined our game, and that was in the area of maintaining engagement and ensuring that students were in fact improving their searching skills across the board, as in all students. We do recognize there's a bit of a trade-off between these two things because the immersive engagement aspect does take time and focus away from the purely academic aspect of the learning experience. With open answer questions, we are delighted that students identified that what they learned most, 13 out of 15 from playing the game, was effective database searching. That's what we were after. But when we asked them what they found most memorable about the activities, it wasn't engaging with Web of Science or manipulating citations. It was, as anticipated, the more fun aspects of the experience, the more unusual things that they wouldn't see in their typical learning environment. So it was the ciphers, the codes, the puzzles, the themes, the sound effects, the howling wolves. Yes, we had howling wolves. But they seemed to really enjoy it. However, when we asked them how the experience could be improved, there was nothing that really rose to the top overall. There was no area of focus. There was, of course, the inevitable student who wanted to be rewarded with something edible. And I suppose the thing that rose to the top, if any, was the desire for even deeper immersion and an even more engaging storyline. And we do wonder what students' expectations are once they realize that this is some kind of game, because we're competing with some very advanced video gaming in the 21st century, something that's really beyond what we can realistically do. But overall, we were very delighted. And we took this feedback and what we had observed, and we set about in the early spring of 2020, making refinements to the game for the next iteration of running it with students. But then came endless March, and everything changed. Our students were off campus, we were working from home, instruction changed when students came back, and some of our colleagues started asking us if we would make an online-only version of the game. So in the spirit of pivoting, which is a word that's now dead to me because I'm tired of hearing about pivoting, we committed to develop this online version of the game in which all immersion would be virtual, all collaboration would be remote through Zoom, and the game could be launched and used in either the synchronous or asynchronous classes that are currently occurring. So we launched, I say we launched, we have been preparing Escape the Core version 2.0, and this new version of the game places players in a totally different perspective. So our players are no longer traversing through the Arctic Research Station themselves. Rather, they are actually coordinating teams of non-player scientist characters who themselves are working through the research station, and they're reporting information and clues that they found back to our teams, and our teams have to solve the puzzles, provide answers to questions so that the scientists, the non-player characters in the station can achieve access to deeper levels of the research station and ultimately reach the nuclear core to shut it down. The progression of the game and activities is no longer dependent on a number of teams, 5 teams, or a specific number of players. So we can actually accommodate with this virtual game at least 30 teams, I think a maximum of 35, and we anticipate discovering the optimum team size for this virtual learning game experience. The game can be run over any period, so if it's synchronous, ideally 60 to 75 minutes, much like the original game. But also, if it's being run asynchronously, it might be reasonable to have a week to 10 days to complete it. Each team is going to have to work synchronously. They're going to have to get together on Zoom at the same time and work together to play the game, regardless of whether the game is being played synchronously or asynchronously. But if asynchronously, not all teams have to be playing at the same time. They just have to do their thing within the time limit to win. So to accomplish all of this, we transformed our web-based platform to become to replace LibWizard and to become the primary interface through which all immersion, game flow, and interaction occurs. We also adapted the platform to create an instructor interface where the instructor can launch the game. So the new mission console has 2 main areas. On the left and right, we have infographics indicating the progression of the scenario. Much like in the original game, we have a countdown timer and a temperature gauge. We also have a team progress diagram showing where each team is within their progress through the research station. And then we have a fuel cell status indicator, each team being responsible for shutting down one fuel cell cluster. So we can see how the overall game is looking. In the middle top of the screen, we have digital representations of all of the formerly tangible clues. These icons are color coordinated to represent interrelatedness of the clues and information for solving a particular puzzle or activity. And then the icon types are designated with different graphics to show the type of information contained therein. The user just clicks on the icon and the image will appear. In the middle of the screen, we have the majority of the information interactions. So we have taunting from Sonia Nielsen, the bearded bandit. We have information relayed from the scientists who are working through the research station. The information and clues that are discovered are relayed back to our teams. And then the computer system messages request answers to questions. For example, answers from questions associated with Web of Science. Our players provide their answers in the bottom middle area. In order to make all of this work really smoothly, we decided that we would need to have some new team member roles. Most importantly is the team captain, who's responsible for coordinating Zoom interactions among the team and sharing the appropriate team player's screen at the appropriate time. And the reason for this is that we have a communications officer who is the sole player on a team to log into the game interface. And they'll be plugging in the answers to the questions in the game interface. So that screen will be shared among players for much of the game. We'll also have one or more researchers officers whose role will be to search within Web of Science. And those screens will be shared as appropriate with the team. All team members have to contribute to all of the problem solving, search strategizing activities and so on. We do have concerns about this. Our biggest concern is just how successful can player collaboration be through the filter of Zoom. We want to ensure that all of our players have a fun, immersive experience, that all information literacy learning outcomes are achieved for everyone, and that problem solving is a fun, collaborative activity that engages all of the players. And much like the original game, only one player is going to interact with the interface, and probably one will be typing into Web of Science. Now, talking with colleagues at other institutions who've already undertaken collaborative remote execution of database searching team activities, we do have cause for optimism that our students are flexible and can adapt to such a scenario and function in this environment. We have lofty future aspirations for this game. We want to expand into multiple scenarios, especially including local history and culture of the Charleston, South Carolina area, as well as broader areas of interest. For example, a French resistance scenario in World War II. But we're very much aware of just how much time and effort it takes to do this. This has been a huge undertaking for us. What we really want to aim for is having instructors and librarians, library instructors and teaching faculty to be able to use this game independently of us, or more independently of us. And to that end, what we want to do is to separate the management of the immersive scenario from the management of the learning content. The idea being that we will maintain a platform in which there will be multiple immersive scenarios, but no learning content delivered on the platform. Instead, the learning content can be maintained by anyone on any platform, such as Google Drive, LibWizard, the college's learning management system. And those things will be integrated together, whereby instructors will determine the correct answers coming out of their learning activities that we can then apply in the scenario to enable students to progress within the scenario. So there's lots to do, lots of excitement around it. We recognize that this presentation period is really too short to do all of this justice. So we have decided to make ourselves available this evening from 4 to 6 p.m. Eastern Time with an informal drop-in Zoom session to answer any questions at length if necessary, and to provide any information that's desired about how we went about this challenge, both of developing an in-person game and this entirely online version. If you want to capture the Zoom information, you could do a screen capture now, but also know that this information is provided in a file that we've uploaded to the console or the, I don't know what to call it, the entry point into this presentation where we can upload information and where chat is occurring. But from now on, we would like to spend the rest of this time answering any questions that anyone may have. So thank you. How much time did it actually take to complete? What, to play the thing or to make it?
Probably to make it, I'm assuming.
Okay,
Make.
so
It says to make, yes.
to make
Take
it.
a shot at that, Geoff.
Well, we started, I guess, in the fall semester of 2019.
Actually,
were-
the summer of 2019 is when, didn't we?
Yeah,
That's when we actually got the grant. Actually, was in April.
yeah, okay. So yeah, we did start, there was a lot of talking and a lot of
Yeah.
brainstorming, a lot of going down different paths and abandoning ideas. And so before we actually got going with this, there was a huge amount of ideation going on, and we didn't really get cracking probably until what, halfway through the fall semester with this particular game. We weren't able to devote ourselves fully to this, as like all of you, we're doing more with less all the time. So it's very hard to identify, but just from a coding perspective, I have written a couple of thousand lines of code and just spent hours and hours and hours testing. So I can't answer the question how much time, because I can just say it was an awful lot of time, and still will be.
Hours, yes.
Yeah. It would be interesting to have documented accurately how much time it took.
Yeah, we can go back and look at our notes and calculate somehow, I suppose.
Yeah. Thank you for your kind comments.
Yes, thank you for your comments.
It has been a huge amount of fun, I have to say. This has been such fun to do, and I think it has such potential.
Absolutely. Looks like we got about 3 more minutes until the end of the session officially. If there are any more questions, please post them in the comments section. Or if you want to hear more detailed explanation, please join us at 4 o'clock for our drop-in.
A game like this has the potential to involve a lot of people.
Geoff, they're asking, did you consider other databases to play with?
Well,
tell them the database problem, Geoff.
We recognize that not everyone's going to want to use Web of Science. At our institution, I think it's the science students rather than anyone else that tend to use Web of Science. So for this to be used in our institution with other disciplines, we do need to consider adapting it to other databases. And that's one of the motivations for separating out the learning content from the platform, because of how long it took to do this. Even just switching to another database and changing all of the game information would be a big undertaking. So we're hoping to outsource that a bit to the actual instructors. We don't have our code available in GitHub yet, mainly because things keep changing.
It's not completed.
Yeah, this project has gone through 3 major phase shifts right now. So, and right now with the online version of the game that we have, we're in the troubleshooting stage. Yeah, we know Web of Science includes non-science content. I was using it. I mean, psychology is still, it's more of a social science, but I was teaching it for psychology just a couple of weeks ago.
We also know it's going to change, right, Geoff?
We also recently learned that Web of Science is changing a bit. So we are going to have to see what the changes are, and we're going to have to adapt our information and the integrated screenshots probably to the new Web of Science. So that's added a bit more work, which will delay probably our launch of this online version.
Well, Geoff, it looks like we're at the 3 o'clock moment, which means that officially our thing is over. I don't know if our moderator, Lola, is there or not. If so.
Hi there, I'm here.
There she is. Hi, Lola.
Hi. The session will end automatically 10 minutes after the time. So if you wanted to stick around and answer any more questions.
Oh, sure. Absolutely. All right. Yeah, I'll stick around for 10 minutes, and then we'll be here at 4 o'clock as well. So if anybody has any, says the old version of Web of Science will stick around well until the next year. Well, that's a happy thought. That means you don't have to jump on it right away.
That's right.
And is the code for the game available in GitHub?
No, our code is not yet available because our code is still
Being developed.
ropey.
Yeah.
I'm still working on it.
It's a bit dodgy.
A bit dicey.
Yeah.
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 But we do ultimately want to consider making it available for others to see what we did and how we did it.
Yeah. Yeah.
Okay.
Lola, is there any, I'm sorry, go ahead, Lola.
Yeah, I'm not seeing any other questions come in at the moment.
Okay. Then I could guess, is there any way to tell if there's anyone still left in the room watching?
I do see
Words of wisdom?
55 participants.
Still
All right. There's 5 diehards there. Good for you. Okay.
There's a question, Jared. You want to answer this one? Will you collaborate with others in the development?
Yes. Yeah, actually, we will. In fact, we'll get into more detail with this in the drop in that we'll have at 4 o'clock. But we are developing a capability to make this anybody who doesn't even have any ability to code, such as myself, to actually use this and supply their own content. So we'll actually be talking with them about that, as well as other people in actual development of the game. So yes.
We got another great question. How would you suggest someone start this process?
Wow.
Well, I mean, I think part of it is dreaming. It's a matter of combining dreaming with what's realistically possible. Jared is the dreamer. I'm the coder. So
I'm the pie in the sky, and Geoff is the feet on the ground.
So we have to find a balance. So I think at first it's wise to include stakeholders. It's wise to include students. We didn't include students at the outset, although we had somebody who was a recent student working with us. So there was a lot of brainstorming, a lot of ideas, a lot of thinking about what we want to accomplish, and then honing it down into something realistic. That was perhaps the most difficult thing, was the dreams and making them more realistic to actually accomplish. I think having a diverse group of people with different perspectives at the outset would be something we would want to do if we were starting over.
Definitely find a collaborator. Don't try this on your own. Find someone you can either coerce or inspire to work with you to do this. Like, I had this idea to do this, but I knew there's no way I could do that on my own. So I knew Geoff, and I roped him in, and he was kind enough to throw his life into doing it. So you do need someone to work with you as a collaborator, and the more the better.
Yeah, and there are highs and lows in the experience. There are times when you're just not sure if you can ever make it happen. There's the frustrating times when you hit a brick wall, whether it's technical or sort of gameplay, game flow. So
I would also, I'm sorry, I would also suggest in the files that we've uploaded, there is also a link to a LibGuide that I've actually created about game creation, specifically immersive scenario games, that I compiled while doing the research for this. And it's got a ton of links to sites, to videos, to podcasts, to DIYs, about how to get involved in the whole game creating process for educational gaming. So I would highly suggest that. It's called immersive scenario gaming.
One of the things, of course, that we did as, scholar librarians is we did our literature reviews and we looked to see what other people had done. And I think a lot of what we found was more to do with library orientations, but we learned from it. We saw things that we liked. We saw things that we didn't like. We also, a key part of this, we were designing this from an escape room perspective. And being that I had never experienced an escape room, we got a small group of library folk together and we went and did a couple of escape rooms. And that really was informative. And
yeah,
yes, it did actually cause us to go even more pie in the sky with our dreaming for a little bit there, but it informed something to do with our game flow and our theming. I think it caused us to put more emphasis on theming after we had done the escape rooms.
Yeah.
We actually used some of our grant money to get some inspiration from local escape rooms.
Yes. Well spent money, I might say.
We really wish the library would have given us a room in order to make an escape room, just given it to us for permanent use as an escape room, because that would have also been pretty neat. But
permanent escape room in a library, gotta have this.
the hardest thing about putting this together was it was the merging of the whole escape idea, the gaming and the theming, with actual academic learning, because it's a lot easier just to make a fun experience, but actually trying to help students learn something is difficult. And one of the greatest challenges with Web of Science and the whole escape idea is that in the escape game, there has to be a correct answer. So you can't just tell students, okay, go search Web of Science for this, that, and the other, because ultimately they have to always arrive at the same article in our case. So it wasn't a purely natural searching experience, but it was exposing them to the interface and the search fields that they could search in, and the necessity of looking at the record that Web of Science provides.
Yeah. Looks like there's no further questions that I can see. All right, you want to call it, Jeffrey, until we get to 4 o'clock today?
Yes, indeed. We shall call it.
All right.
Thank
Lola,
you for joining us.
thank you very much, folks.
Thanks so much.
Thanks, Lola.
Thanks, Geoff. Thanks, Jared.
All right. Bye-bye.
Bye.